NVIDIA is one of the most powerful companies in the AI industry. But there is one critical part of the AI race NVIDIA doesn't control: the machines used to manufacture the most advanced chips. And the company behind those machines isn't American. It's a Dutch company called ASML. NVIDIA designs the chips. But to understand how those chips become real, you have to follow the technology several steps deeper. Because NVIDIA doesn't simply build a GPU and send it to a factory. The process involves some of the most advanced manufacturing technology on Earth. TSMC manufactures many of NVIDIA's advanced chips, and TSMC relies on an enormous network of specialized equipment suppliers. One of the most important is ASML. So how did a company that most consumers have never heard of become so important to the world's AI hardware race? And what happens if the demand for advanced chips keeps growing faster than the technology needed to manufacture them? To answer that, we have to start with the chip itself. Look at an NVIDIA GPU, and it is easy to think the story starts with NVIDIA. It doesn't. Before an AI processor can power a data center, its design has to become a physical piece of silicon. NVIDIA designs its processors, but NVIDIA uses manufacturing partners to produce them, including TSMC. And manufacturing an advanced chip isn't like printing a document. A silicon wafer goes through a huge number of highly controlled manufacturing steps. One of the most important is lithography. Lithography uses light and optics to transfer incredibly precise patterns onto the wafer. Those patterns eventually become part of the circuitry inside the chip. And as chip makers try to fit more transistors into smaller spaces, the patterns have to become smaller and more precise. That creates a problem. The better the chip needs to become, the harder it becomes to manufacture. ***. And solving that problem became the business of a company called ASML. But ASML wasn't always the company everyone depended on. ASML was created in the Netherlands in 1984 as a joint venture between Philips and ASM International. Its early business was semiconductor lithography. The goal was simple: build better machines for chip manufacturers. But the semiconductor industry kept moving. Chips became more complex. Transistors became smaller, and manufacturers needed new ways to print increasingly tiny features. ASML eventually committed to a technology that would take years to develop: extreme ultraviolet lithography, or EUV. The idea was to use extremely short wavelength ultraviolet light to create smaller patterns on semiconductor wafers. On paper, it sounded like a solution. In practice, it was an enormous engineering challenge. ASML had to develop the technology while working with a network of suppliers, researchers, and chip manufacturers. The company says it invested more than €6 billion in EUV research and development over 17 years. Its first pre-production EUV system shipped in 2010. But that wasn't the finish line. The technology still had to become reliable enough for high-volume chip manufacturing. Eventually it did. And that is when ASML's long gamble started to change the semiconductor industry. So what makes EUV so important? Think about a chip as a microscopic city. The transistors are the buildings. The connections are the roads. And lithography is part of the process used to create the map. If you want more buildings inside the same amount of land, the map has to become more detailed. EUV allows chipmakers to create extremely small patterns using 13.5 nanometer light. But the machine producing that light isn't ordinary. ASML's EUV systems use a highly specialized light source and an extremely precise optical system. The entire process has to operate with extraordinary control. And these machines are so complex that ASML doesn't simply manufacture one complete box and ship it like a normal product. They are assembled, transported, installed, and tested inside semiconductor fabs with extensive support from ASML and its partners. That complexity is exactly why this matters to NVIDIA. Because NVIDIA can design a more powerful processor, but someone still has to manufacture it. And that takes us to TSMC. Erase the hidden chain behind the AI chip race. NVIDIA designs the processor. TSMC manufactures many of NVIDIA's advanced chips. And ASML supplies critical lithography systems used in advanced semiconductor manufacturing. So NVIDIA isn't directly dependent on ASML in the simple way people sometimes imagine. NVIDIA doesn't buy an EUV machine and manufacture its own GPUs. The dependency runs through the manufacturing ecosystem. And the relationship goes even further. NVIDIA and ASML have worked together on computational lithography, using powerful computing to help solve some of the enormous calculations involved in semiconductor manufacturing. NVIDIA has also worked with TSMC to bring AI computing into semiconductor manufacturing processes. That creates an interesting loop. NVIDIA helps build the computing technology used for AI. And NVIDIA's computing technology can also help accelerate parts of the process used to manufacture future chips. But there is an even bigger reason ASML matters. The AI boom is increasing pressure on the entire semiconductor supply chain. AI models can become larger. Data centers can add more servers. Companies can spend billions on AI infrastructure. But none of that matters if there aren't enough advanced chips to run it. And you can't simply demand a faster chip into existence. The manufacturing process has to keep improving. That's why ASML is continuing to develop the next generation of EUV technology. Its high-NA EUV systems are designed to print even smaller features and support future generations of advanced semiconductor manufacturing. The goal is always the same: more transistors, more computing power, more performance, but with features so small that the manufacturing process itself becomes one of the biggest challenges. And this reveals something important about the AI industry. The biggest AI companies may get the headlines, but behind them is an entire network of companies pushing the physical limits of technology. And ASML is one of the most important pieces of that network. This is why the AI race isn't only a battle between NVIDIA, AMD, Google, Microsoft, and other famous technology companies. There is another race happening underneath them: who can manufacture the next generation of chips. Because software can improve, chip designs can improve, AI models can improve, but eventually, all of those ideas have to become physical hardware. And that hardware has to be manufactured with extraordinary precision. NVIDIA may design the processor, TSMC may manufacture it, but companies like ASML provide some of the technology that makes advanced manufacturing possible. That's the hidden power of the semiconductor industry. Sometimes the most important company isn't the one selling the final product. It's the company building the technology that makes the final product possible. So does NVIDIA literally need ASML to survive? Not in the simple sense. But NVIDIA's future depends on an ecosystem capable of producing increasingly advanced chips. And ASML is helping push the limits of what that ecosystem can manufacture. Which raises a bigger question. As AI keeps demanding more powerful chips, will the real battle eventually be over the companies that build the machines capable of making them? If you want more stories about the hidden companies behind the world's biggest technologies, subscribe to Ledger Logic.